So I'm going to speak about cost effectiveness and cost effectiveness. It's one of those phrases where the pauses and the commas are important to distinguish. These are three different concepts and tools, obviously related. I'm going to speak mostly from examples from the first place that we did a survey on that Irene has mentioned already, Glanmore, and you heard the curator, Rona Rustage, speaking about it. But then I will also consider all of the data we've collected so far from the several different surveys. When we first went to Glanmore, honestly, Irene and I were totally pumped about risk assessment per se. And Julie, who was our education officer at the time, was with us to help on communication issues and so on. And at one point we were sitting down in a meeting and she said, so what's going to be in the report? And we said it's going to be all these risk assessments and graphs and analysis and so on. And she looked a little disappointed and said, are you going to tell them what to do after you tell them what all their problems are? And we thought, well, yes, probably we should do that. And actually, we realized that in the past, when we did preventive conservation reports, we knew we were heading towards recommendations. And then when we got excited about risk assessment, there was a tendency to stop at the assessment point and hand over to the client and then say, now you know what your priorities are, you can figure out what to do about them. And that was at this point where we realized we knew we had thought about developing tools that would connect to the assessment, that would do options and option analysis. And we certainly taught it in the last 2 days of a 3-week course. But now we got more serious about it. So I want to show you some of the results that came out of actually adding to all of the risk assessment reports a set of options which were analyzed, and they were analyzed for their effectiveness, and they're analyzed for their cost, and they're analyzed for their cost effectiveness. You've seen the 5-stage cycle for risk management. We're jumping straight ahead to step 5, which is to treat risks. I put in initials here, preventive conservation, because very much treat risk stage is what we would conventionally have thought of as preventive conservation. So the difference is that you do analysis and assessment to find out really what you should be doing and your priorities for preventive conservation. But when you get into the treat risk stage, it is making suggestions and recommendations, which we traditionally would have said, these are my preventive conservation recommendations. Within step 5 then, there is identify the risk treatment options, quantify those options, and then evaluate them. These are the terminology of the risk analysis literature and the ISO standard. Evaluation, identification. And then plan and implement selected options. So that's when you do hand over to the client, to the museum. They would do that. And you've seen the people we've been dealing with are more than able to understand and take that further step. So I'm going to be looking at the evaluate options, 5.3. And within that, we're going to look at evaluating it by its effectiveness, by its cost effectiveness. And the question is, which one should you use? A, B, C, or D? Because I'll give you the punchline now, those three different things don't always agree on which option is the sweetest, the best, the optimal. They can be in conflict, which is not what we always expected at the beginning. And of course, the answer is you should consider all of the above. So what is the effectiveness of an option? It's, for our purposes, it's the risk reduction. How much is the risk reduced? And that's the untreated risk, subtract the residual risk after treatment. So it's the difference in risk. How much have you lowered it? Because it's clear, it's important to understand with risk assessment, you might make it very small so you think of it as pretty much zero, gone, perfectly solved. It's never like that. you are reducing risk. You're not making it all go away. Cost effectiveness, on the other hand, is the traditional, the business definition, is the effectiveness divided by the cost. And since for us the effectiveness is how much we reduce the risk, it is the reduction of risk divided by the cost per year to do that. Another way of expressing it is it's the prevention of loss in value per year divided by the cost per year. And you saw in Zay Lewis's talk and also in Rob's talk some vertical axes showing a fractional savings of the collection per year. So I'm going to look at the general relation of these three different parameters. And I'm going to plot first various graphs, always on the same horizontal axis, which is risk. And on this risk axis, I'm showing loss in value per year fractionally. So if we're over on number 1, that means that the risk is so bad that we'll probably destroy the entire collection in 1 year. And that's the upper limit. Clearly, we wouldn't have clients if anybody had this risk. But it has occurred. I have been approached by people that sort of dealing in war zones where they make a decision that could literally change whether or not their museum exists in a year. So it's not completely unfeasible proposition. It's simply not part of normal museum life. But it's the far end of the scale. And then the scales get smaller here. These are a logarithmic scale. You would have noticed on some of Rob's vertical scales, there was a decimal and then 0.1 and decimal 0.001. And he spoke about orders of magnitude. I will be speaking about the same kinds of scale. These are orders of magnitude. So each of these steps is 10 times less, 10 times less, and this is 10 to the minus 5. So 1 part in 100,000. So 1 part in 100,000ths of our collection we saved this year, and so on. Now on the vertical one here, I'm going to plot the reduction of the risk. So if we had a perfect risk reduction, all of our options solved all of the risks, we would have this 45-degree line. So risks that are scaled 1, we lose everything in a year, it's gone. The risks where we lose 10 parts in a million, 10 to the minus 5, perfectly solved. Now I'm going to show you the options that we developed for the Glenmore House. No, I'm not. I'm going to show you a bit more of an animation of what I'm talking about here. So a 10 to the minus 10 risk, a 10 to the minus 5 risk, something here. And if we solve that risk with an option, I'm going to show you the option up there. And if we solve that risk with the option, I'll show you the option exactly on that deadline. And if more realistically we have a fairly high option, but we can't reduce it perfectly, but we can do a pretty good reduction job, it will be slightly below this line. So now I'm going to show you the real data for the. These are 68 options that were developed for 37 risks in this particular historic house museum. And you can see one here, which is the fire risk. The top one, it's not perfect, but it's close to, it's a big substantial reduction. This was an option that really didn't do very much, less than 10% reduction. Like each of these steps is a log unit. And down here is something that really didn't do anything at all. In fact, this one actually generated more risks. We didn't have negative numbers for the scale, but this was a bad idea option. But completely plausible and reasonable if you didn't stop and work out the numbers. Kind of thing we would have suggested 10 years ago. Here are the costs for those options. And that's the scale. It's also a logarithmic scale. So it jumps quickly from $1 a year to $100,000 a year. And here is when I divide the cost, divide the reduction by the cost, I get these numbers. So this is the cost effectiveness. And this scale is for those who want to work out the numbers. But the important thing is that the higher we are up here, the better the cost effectiveness. And I'll elaborate a bit more on this. What I want to point out is that if the option costs were proportional to how much risk we're reducing. So in other words, if you had an option that was 1,000 times more important than another one in terms of reducing risk, you would think it makes sense to spend 1,000 times as much money. When you actually look at the cost of those options, they're not on the same slope of line. They're here. It's actually almost flat, which is the bad news. It means that this cost effectiveness line is in fact sloped. If the cost of reducing each risk, each option we looked at from acid-free tissue up to fire reduction, if the cost was proportional to what we were actually achieving, this line of cost effectiveness should be flat, should be horizontal. It's really far from flat. And that's the whole point of my talk, in case I speed up a little bit. Options that reduce large risks tend to have a better cost effectiveness. And I'm just referring this in a business sense, which is the economies of scale. If you ever wondered whether fixing the whole building for $1 million was better than picking away at the edges with acid-free tissue, not only in terms of effectiveness, but cost effectiveness, bang per buck, is better because this line is not horizontal. I can look at another place. This was Elden House. This is on the right, I'm showing Elden House characteristics, and on the left, for reference, slightly dimmed, is Glanmore. Fundamentally the same shape curve. Same stuff going on. Slightly different here. This is interesting. I haven't told Irene about this yet, but what this says to me is these risks and options that Irene was looking at, which cost a lot, but which are small options because they're on the left side of this graph. We were looking conscientiously. This is a plausible option. People have talked about this in preventive conservation and recommended this. You can see that Irene is subconsciously or consciously no longer bothering with those goofy things and not putting in things that have high cost at the low end. So in fact, this region is less populated. And what you see up here is this region above, which had lots of really poor cost effectiveness on little tiny risks. There's only one of them hanging around at Elden House. So already it was just like, no point even entering that one in the database. I know those are goofy suggestions. But they'll come back again when we go to a different kind of museum. This is the art gallery. Now this is the art gallery in comparison. You can see that we've populated again with high-priced options which address fairly small risks. Now partly that's because this whole operation is 10 times bigger. And I think what happened is you can be in one room and the mechanism that says that's probably a goofy thing to look at, it's not going to be cost effective at all. You're in one room of a museum that's got 10 or 20 rooms compared to the historic house that had 2. That switches back on. Well, that seems plausible. It's going to fix quite a bit of stuff, I think, in this room. But when you scale it to the whole place, you can see that what's happened is these are coming back. And these poor cost effectiveness options are repopulating. What's interesting about this place as well is that this is a well-controlled museum already. They don't have the really high risk issues like fire and roof collapse, which we saw in the earlier ones. So they don't even begin until 10 to the minus 4, so 1 part in 100,000. So you can see it's clipped off because this is a well-operated, funded museum. So already we've backed off on the bigger risks. Now we're going to look at the Saskatchewan Archives numbers. And again, a lot of scatter. But the fundamental slopes of the green line and the gray line of cost effectiveness unchanged on these 4 very different kinds of operations and scales. When a well-experienced person discussing options with staff with long experience propose different options, because you may well ask, you could just seed this 4 things with really irresponsible option development that you know are going to have appalling cost effectiveness. It wasn't like that. I didn't actually start crunching these numbers till most of these assessments were over in terms of putting on a pattern. We certainly were generating the cost effectiveness on a table, but until you step back and look at them all on a graph, you can kind of convince yourself they're still reasonable. But this pattern just kept coming over and over. Now I'm going to see whether we can make a master graph of this. Can we plot all 4 institutions' data on the same graph? This one, I'm looking at the scale has changed. So because the museum is 10 times bigger, or 100 times bigger, we've gone up, actually the scale of the options have gone up almost 2 units by the yellow arrow. So it's 100 times more expensive on average, each of the options we looked at. And then the cost effectiveness comes down a couple of orders of magnitude. But that's because 100% of the Saskatchewan Archives is objectively somewhat more valuable within the grand global scheme of things than 100% of Glenmore. So now I'm going to see if we can scale those so that each person's 100% is meaningfully related. And I have done that, so I'm going to show you the results first. So that's 111 risks for which 244 options were developed. So you can see on average, Irene was developing 2 options per risk. And the general pattern is very well established. The prices of options are all over the map, literally, almost horizontal in the end. By the time you actually do something, even if it's not very effective, it can cost as much per year. Now, some of these are really high, so there's things that cost a lot, things that cost very little. And what I did to do this is that one of the questions that came in from the audience was, what about insurance value? And I'm glad whoever asked that, because I can segue into it. The art gallery had done, and as you heard her, the director of operations or finance, they're very current and up to date. In fact, the year that we approached them, they said, we've just finished doing evaluations of all of our artworks and pieces. We know the market value of the entire collection. Are you interested in that? Absolutely, we're really interested. Not that we want to promote the crass, horrible capitalist notion that value has a dollar sign in front of it. But if somebody comes along with a pilot project where they say, oh, by the way, in case market value would be interesting to look at, we've got it. And it's from paint, they've got Emily Cars, and they've got archival documents for the city of Oshawa, so a nice range. So their total value we knew was roughly 40 million market value. So what I did for these numbers was say, roughly, the historic house museums are order of magnitude smaller. They're about 10 times smaller. The value of the house plus all of the property and selling it, they might get 1 million, they might get 4 million. That's not important. We all know they're going to get more than 100,000, and they're not going to get 10 million. So it's ballpark. On the other hand, what's the value of a large provincial archives? I borrowed here from ideas that Rob's Natural History Museum did years ago with Gerald Fitzgerald to look at, Jerry Fitzgerald, to look at an argument for Treasury Board. And they costed what it would be to actually replace. You know, what is the labor and maintenance costs embedded in a huge collection? And I think it's not unreasonable to say that an archive with tens of millions of records, if you said, what would it cost to go back and find each of those, catalog them, label them, put them all in the same place again, not to mention how much we've spent. Anyway, order of magnitude 10 times bigger. So that makes these clouds of cost effectiveness things line up. So now that we've got a dollar value here, we can go and do something really inappropriate and dirty, which is put dollar to dollar. So if I've scaled these value of these collections, and I know that this black line used to be percent of collections saved, what about dollar of object value saved per dollar spent per year? Well, that dotted line is the line where you break even. Above that line, every option is a pure business, go for it decision, if you can find somebody with the funding. But if they're saying, is this really a business case? So, you know, absolutely. If somebody in real estate could have some of these things where you spend 10 cents to save $1 a year, which some of these things are 1.5 orders of magnitude higher. We're talking about saving $1 of collection by spending 10 cents per year. Let's put something that maybe is a little scary. We actually have options where you're spending $100,000 to save $1's worth of collection. These are gigantic differences because this is a log scale. Each one of these lines, 10 times, 10 times, 10 times. That's the evidence I'm going to leave you with, which is we can, in our field, actually come up with pure business case, preventive conservation, or risk treatment. And we have to think about how do we recommend other things. So, for example, this area of options is a straight business case because it's cost effective. This area of options are because of effectiveness. These are the biggest risks being reduced for each of these collections. And these are the no-brainers. You've got cost effectiveness and how big the risk is that it's addressing, supporting those options. These ones, you say, they're not the biggest risks, but it's good value for money. On the other hand, you wouldn't want to be spending money here knowing that this may be less value for money, but this is your biggest risk. And so, for example, high risk and medium cost examples, good cost effectiveness. Monitor moisture content of the joist to reduce probability of collapse. So you saw and that was the risk here, that was the cost, that was its effectiveness. Do it. High risk, low cost, so good cost effectiveness. Improve exterior door hardware to reduce probability of theft. It was a middle of the road risk, it was a super low cost, and it was terrific cost effectiveness. Low risk, high cost, so very poor cost effectiveness. Provide tour guides to control visitors who may abrade picture frames. By the time you put in minimum wage costs, we didn't say, oh, let's just assume you can find a slave or a volunteer and we won't put $1 cost down. We said that's irresponsible. We want to cost what it costs to do stuff. And you ask the staff to do something more than they're already doing and they're all busy. Then you have to say, okay. And so that one gives you a risk down here. It's not very big. It has a cost up there, which is thousands. I mean, it's basically a part-time salary for one person. And you have a cost effectiveness, which was the lowest one on the map. This is low risk, low cost. So you'd think you could get away with it. But the risk is so low, cost effectiveness is still poor. Improve filtration on air handling system to reduce pollutants, dust on objects. In other words, spend some money to buy filters more frequently and better ones for the furnace. Here's the risk, pretty low end. Here's the cost, and here's the cost effectiveness. You can't get good cost effectiveness at the low end of risks. You might wonder, what's our bottom line here? $1 a year. I mean, we even costed things here and said, okay, just thinking about it, it'll cost you $1. You thought about it for 5 minutes, bang, that's $1. It's not like a cent, like it's serious. It'd make it $10, it wouldn't change the argument. But a lot of these are things where like, oh, it'll take them 2-3 hours to work it through once a year. And it still didn't make necessarily sense. If somebody spends a day out of their year and there's only 3 staff, it better be a useful day. And some of these options didn't make it. This is one where it was a tricky decision, but because of the effectiveness, very high risk, medium cost effectiveness, install a fire suppression system. So you don't have that. Miners Museum, Glace Bay, decades ago. That was the risk. It was the biggest one for Glenmore. There was the cost, even amortizing. That was amortized. You may wonder how do we do per year for something which is a capital cost. That's where what we call the time horizon for the risk management comes in. What is the time period over which you're trying to act responsibly as a management team? And governments tend to use 5, 6, 7 years. Heritage agencies and people like that might go for at least 30, 100. It doesn't make much sense to amortize costs over 100 years, even if you're preserving to 100 years, so we use 30 years, which is pretty generous to spread the cost out, but to save it. So this was a cost per year, given the fact that you would pay for it over 30 years. And there it is. We certainly recommend it. It was our top recommendation. but not because it had fantastic cost. The cost effectiveness was good enough, we thought. A little bit less than a business case, but not so much less. It was only like a factor of 4 or 5. So what do we do next? We would like to make the tool work better in terms of the tools we use which generated those graphs. The effectiveness of one option that reduces several risks comes up realistically often, and we'd like to do it better. Cost effectiveness of all options together, so you could look at a suite and calculate the cost effectiveness. These are not a big deal. These are just getting the arithmetic right and making sure the tool allows you to enter the numbers without making conceptual errors. The other thing I'd really like to do, and it's part of sustainability and part of CCI strategic plan, and with a slight shift in political climate in our country, it might become more important as well. One could also just do carbon footprint effectiveness. One could build in, borrowed from carbon footprint calculators, what is the carbon footprint of each option? So you can find out how much preservation can you do for the least effect on the planet. Thank you very much.